Hey everyone, and welcome back. All right, today we're going to look at some more vocabulary. We're going to dive into two new theorems. So we've done Pythagoras' theorem already, and then we've done two formulas, distance and midpoint. Today we're going to introduce two new theorems, linear pair and vertical angle theorem. And we're going to look at, what's the difference between a postulate and a theorem. We're going to have to prove that theorems are true. So how do we go about doing that? There's lots of good stuff in here today. Essential questions for today: what are supplementary angles and what are the different types of angles we might come across? So first thing in our vocabulary journey is just reminders about the quadrants, which you may know from Algebra 1. I hope you do, but if you don't, that's okay. Let's remind ourselves now. So you've got four quadrants. When you take the two axes, it divides up the coordinate plane into four quadrants. Top right is quadrant 1. It's where both x and y are positive. Quadrant 2 is on the top left. X is negative, y is positive. Quadrant 3, bottom left, both are negative. Quadrant 4, bottom right, x is positive, y is negative. All right, then we got vocabulary. We have an angle. So this is a figure formed by two lines or rays that intersect at a point. This point is called a vertex. How we show it, you've got at least 1 point, so you're always going to have one, and that's the vertex, so B would have to be there, and then you usually have two arms, so we call these the arms of the angle, and they will be coming off from it. Now you may also see it as two lines or line segments that intersect, and that will also come together at a point, and then you will have angles resulting from that. The way you reference an angle, and this is important, is you have to use 3 letters in most cases. There are some, so like if we are talking about a triangle and it's got ABC, I can refer to the angle up here as angle B, or I could refer to it as ABC or CBA. Now, by default, an angle is named counterclockwise. So you start at, say, PQR. You start at one arm, so in our case, P. And if we're talking about this angle, we would imagine doing a counterclockwise swing. So that's how you name an angle. So it's always going to default to counterclockwise, particularly in some of the computer programs we do. So this would be angle PQR. If I did the other one, so angle RQP, it's technically talking about the reflex angle, so that's this angle on the other side. In class, I'm not going to really care if you get that wrong. The Q has to be in the center, so the vertex has to be the center one, but we're almost always going to be talking about the angle that's not reflex, so the one that's less than 180 degrees. So if that's the case, using the 3 letters with the right vertex letter, I'm going to know what you're talking about, and it's going to be totally fine. Just know in some of our computer programs, they will force you to do counterclockwise because otherwise it will name the angle incorrectly and you'll get the wrong measure. So particularly when we use GeoGebra and we start trying to measure angles, you'll have to click it in a counterclockwise fashion. But other than that, everything should be pretty straightforward. You cannot use a single letter in, say, like this other type of angle that I showed you down here. So say we've got like A, B, C, D. And if I want to talk about this angle in here, and we'll make that center point F. So if I say angle F, I have no clue what you're talking about. Like, are you talking about the top one, the right one, the left one, the bottom one, some combination of them? There's not enough information given. So instead, you have to think about it with 3 letters. So if I want to do the one with green in it, it would be angle DFA. So that would be DFA. I'm talking about that angle in there. So just keep that in mind when you are naming your angles. 3 letters. Middle letter is the vertex. All right, we've got a couple of different types of angles here. An acute angle from 0 to 90 degrees, not including 90 or 0. A right angle is 90 degrees exactly. An obtuse angle is 180 to 90, not included. And then A straight angle is 180 degrees. A reflex angle is anything above 180 but less than 360. And then a full rotation, 0 or 360 degrees. So if I ask you, what does it mean to copy an angle? That means that we are going to create another angle with the exact same angle measure, so that's the size of the angle, somewhere else. So we're copying the measure of an angle. And then to bisect an angle, bisect, you might remember from before, it means to cut in half. So to bisect an angle means we're going to divide an angle into two equal angles. Here's three words that you'll come across, or three phrases that you'll come across in questions sometimes, in notes sometimes, in just general geometry conversation. If points are collinear, that means that they are all on the same straight segment or line. So you can draw a line that would pass through all of the points if they are collinear. Coplanar are all points that are on the same plane. So you looking at the screen, every single point on the screen is coplanar. So all of those pixels are coplanar. They're all on the same two-dimensional surface. Intersect. So you can share one or more points. So for example, a circle intersected by a line segment would have 2 points of intersection. Two lines meeting would have 1 point of intersection, and then you can have like a horizontal plane meeting a vertical plane, and then you've got this line of intersection. So it doesn't have to always be a point, it can be a line as well when two planes meet each other, or like the edge on a shape. So if we think of a cube or something like that, cubes have lines of intersection where their faces meet each other, and then we call those edges. So the edge on a shape is a line of intersection between two planes. All right, a postulate, remember, is something that we accept to be true, and we do not have to prove it's true. It's going to form a foundational building block for our class and any future proofs that we do. So the angle addition postulate says that if point S is in the interior of angle PQR, which it is, then the measure, so that's what this is, measure of angle PQR is equal to the measure of angle PQS plus the measure of angle SQR. So let's pull out a highlighter for a second and color code these. So PQS, so the measure of PQS is in here. And then SQR is on this side. So what we're saying is the measure of angle PQR, so the whole thing, is going to be the two smaller angles added together, which basically we're just saying addition works here. And we know, of course, that that's true. So the ray QS does not subtract anything from the total angle or add anything to the total angle. Remember, it has no width dimension, it only has one dimension, that's length. So try this at home for yourself. Draw a segment and intersect it with another. So segment, intersect it with another. What must be true about the adjacent angles that are created? So these two. Think about it for a second. See if you can give me a statement that would be true about those two angles based on the angle addition postulate. Okay, so what we're looking for here is that if you break up a straight line, so a segment or a ray or a line, with another segment, ray, or line. So it can have an endpoint on it, or it could continue as well. It wouldn't matter. It's going to create supplementary angles. So these are angles that add up to 180 degrees. So angle 1 plus angle 2 would equal to 180. And this is what we call linear pair theorem. So if you have adjacent angles on a straight angle, then the adjacent angles would be supplementary. And it doesn't have to just be two angles. So we could, have said, let's divide this up and put a third angle in here, then 1 plus 2 plus 3 would all be 180 as well. So this is what we call a proof. We use a statement reason table to show that there is no way to possibly say that this is not true. So you're trying to show without a shadow of a doubt that this is true. So we would say A, B, and C are collinear, so they're all on the same straight line. And then ray BD intersects it at point B. And we want to prove that the adjacent angles, angles 1 and 2, which is ABD and DBC, are in fact supplementary. They add up to 180 degrees. So we know angle ABC is 180 degrees. We said they're collinear, which means it's a straight line, which means by definition of a straight angle, that's got to be true. ABD plus DBC is equal to ABC, so the angle ABC. We know that's true because of angle addition postulate. So we've got two angles side by side. We can add those together. And that would be the same as the full angle. And then we can say, well, since ABC is 180 degrees in our first line, we can substitute the two of those. They are equivalent to one another. So instead of ABC, let's put 180 in there. And that means that those two angles, when added together, are going to equal 180 degrees. So that is a substitution. So we can say adjacent angles on a straight line are going to be supplementary. And that is the linear pair theorem. If you have two angles that add up to be 90 degrees, they are what we call complementary angles. So if you divide up a right angle into two or more angles, they are going to be complementary. So angles 3 plus angle 4 equals 90. Same kind of idea, same proof, but just something to keep in mind. Supplementary 180, complementary 90. All right, protractors. If you have a protractor at home, now's the time to pull it out. We use these for measuring angles. We're not going to do a huge amount with protractors. We might use it to help us draw certain shapes, but we're not going to be measuring angles because we're going to be doing a lot of it algebraically and trying to solve for missing angles. So what you'll find is in most cases, the pictures you're given are not accurate, and that's to prevent you from pulling your protractor out and skipping to the answer. They want you to solve using properties of shapes. So we're trying to measure an angle. You pull out your protractor. You slide it down so that the crosshair of the protractor, which is the part that is at the center where the vertical line and horizontal line meet, that's called the crosshair. That goes on the vertex. So crosshair goes to the vertex. And then the 0, 180 line at the bottom of the protractor lines up with the arm of the angle. Now, because we lined it up with the 0 that is on the inside, so you ask yourself, which 0 did I use? Because we use the 0 on the inside, that means we're going to measure using the inside numbers. So 10, 20, 30, 40, 50, 60. So this is a 60-degree angle. And you can kind of use common sense here as well. Like the other option is 120, which wouldn't make sense because this is clearly an acute angle. Okay, I want you to try and prove a theorem for me. So this one says that if you have two lines that intersect, L and M, that the opposite angles are in fact equal, so they will have the same angle measure. So you need to prove that that's true. So I want you to think about what you know already about these angles, list out all the things you know, and then try and assemble them in a way that shows that angle 2 and angle 4 must be equal. And we can just pick those two. You can do 1 and 3 as well if you wanted. But you draw a statement reason table, so a table where you divide it down the middle. The first thing you write is always going to be your given statement. So lines L and M are lines that cross or intersect. That is our given statement. And then what does that mean? Pause the video, try and come up with your own argument, and then come back and see how we go and prove it. All right, so you should have listed as many things as you could possibly tell about this diagram. And the first one would be, well, any of these angles that are side by side, so there's 4 pairings here, are linear pairs. And that means that those angles, if you add them together, are supplementary. They add up to 180 degrees. So I chose 1 and 2 to start with. So 1 plus 2 is 180, and also 2 plus 3 is 180. So actually I'm going to prove 1 and 3 are congruent in this one, so I'm going to show that this one and this one are the same. So 1 plus 2 is 180, true, because that's a straight angle, and then 2 plus 3 is 180 because this is a straight angle, so angle addition postulate and linear pair theorem tell us that must be true. Now this is the big one. if A is equal to B and B is equal to C, you would therefore, that's what these three dots mean, therefore, you would be able to say A must also equal C. Or an example I like to use is me and you are the same height, you and your sibling are the same height, so therefore your sibling and I must be the same height. This is what we call the transitive property. So if two different things are equal to another, then they must also be equal to each other. So we saw substitution in the last theorem. That's where you can replace one thing with something else of equal value. It's kind of like a substitution, but it's a little bit different. So we would say angle 1 plus angle 2 is 180 degrees. Angle 2 plus 3 is 180 degrees. Therefore, they must also equal each other because they both equal 180 degrees. So it makes sense, right? So we write that down. 1 plus 2 equals 2 plus 3. So that's our transitive property. And then, well, they both have an angle 2. We don't know what the value of angle 2 is, the measure of it, but they both have it. So it's an equal value in both. I can subtract it from both sides, so just like you would a variable in an algebra problem. And I'm left with angle 1 equals angle 3. So the opposite angles 1 and 3 must be equal. And same proof for angles 2 and 4. We could just show it using, we could use 1 and 2 and then 1 and 4. And we would be able to show, well, since 1 is common, that means 2 must be equal to 4. So that is a proof using a statement and reason table. We will be doing a lot of these throughout geometry. All right, essential questions for today. What does supplementary mean? It means it adds up to 180. What are the different types of angles? We've got acute, we've got 90 or right, we've got obtuse, we've got straight, which is 180 degrees, we've got reflex, and then we've got a full rotation or no rotation, which is a 0-360 scenario. For tonight, I've got a worksheet for you. You'll find it in Schoology. This is about solving for missing angles using the angle addition postulate. I'll see you next time.